Welcome to the online lecture series on 8051 microcontroller. In this video tutorial, we shall discuss the program for finding the largest or smallest in an array. Okay, so if you know the logic of largest, just by an instruction change, you can also write the program for the smallest. Okay, let's understand the logic of this program. Okay, suppose this is the array whose starting address is 30H, and let us assume the data initialized like this. Okay, so at 30H you have 3, then in corresponding locations we have 1, 2, 8 and 9. So we have to find out which is the largest number. Okay, and as usual, if we can see, we should get the answer as 9. So what is the logic? The logic is very simple. Okay, what we will do is uh, we will always assume that accumulator contains the largest. Okay, in the sense, whenever we find the largest number, we will move to the accumulator, and we will start with an assumption that the first number itself is the largest number. Okay, so we will assume accumulator to be the largest. Okay, and we will start with the assumption that the first number itself is the largest. Okay, now then we shall start comparing with the other data. Okay, so in the first comparison, so this is my first comparison. In the first comparison, I will compare 3 with 1. Fine. And if the number which I am comparing, it is greater than the accumulator, then accumulator will be updated. But in this case, as you can see, 3 is already greater than 1. So we will not update accumulator, and accumulator will still contain 3. So this is my first comparison. Fine. Now, coming to the second comparison. So this is over now. In the second comparison, the contents of the accumulator, which is presumed to be the largest, next it will be compared with 2. And still you see that accumulator content itself is the largest, and hence it will be retained. Okay. In the third comparison, the contents of the accumulator, which is now 3, is compared with this location 8. And as you can see, 8 is greater than 3, and in this case accumulator will be updated to 8. Okay, so we have one more comparison left, the last one, the fourth comparison. Now accumulator is updated to 8. As I have told, we will assume that accumulator always contains the largest. Fine. Now in the fourth comparison, accumulator contains 8, it is compared with the next memory location, it has got 9. So 9 is greater than 8, so accumulator will be updated with 9. So whatever you have at last in the accumulator, that itself is the largest number. Okay, so how many comparisons we did? 1, 2, 3, 4. It means if we have n numbers, so if we had 5 numbers here, 1, 2, 3, 4, 5. So for n numbers, so how many comparisons will be there? N minus 1. These many comparisons will be there for n numbers. So this is the general formula. Okay, I hope the logic is clear. So with this logic, we shall write the program, execute it, and also we will check the result. Fine. So let's write the program. First I will initialize the count. Say move r2 comma hash 5. So this is the array size. Fine. but as we have seen, the number of comparisons are n minus 1, so it is n minus 1 comparisons. So array size was n. Fine. Now I have to initialize a pointer to the array, so move r0 comma hash 30h. So pointer to array, the starting address of the array. Fine. Now what did I say? We will start with an assumption that accumulator contains always the largest number. So I will copy the first data, move a comma at the rate of r0. So accumulator contains the largest. That's the first number. Next I have to go to the next number. Okay. So for that, what should I do? I should increment the pointer, right? Okay. For that I will say, let me show you the Excel sheet. See, the first number I have got in accumulator. So I should get the next number, right? So that's why I have to increment the pointer. So increment r0. Now the pointer is pointing to the next memory location. So I have the first number, which I am assuming, because this is the first comparison. So I am assuming accumulator always contains the largest, that I am comparing with the next number, which is pointed by r0. So my instruction should have been compare jump not equal to a comma at the rate of r0 comma next something. But this is not supported. Indirect addressing mode is not supported. Okay, what is supported is immediate and direct addressing mode here. Okay, so it can be some memory location 60h and all. Okay, this is fine. So for that, what you should do, whatever r0 is pointing, that you should copy it to 60h. Fine. So I will say move 60h comma at the rate of r0. Why I am doing this? Because the instruction doesn't support. That's it. That's it. If the instruction would have supported the indirect addressing mode, this logic was not required. That's why we have to study instructions properly. Fine. Now, what does this instruction do? This will compare these two numbers. Okay. Accumulator is the destination and 60h is the source. So how does this work? How will you find out which is greater and which is smaller? You can find out by the carry flag. If the contents of the accumulator is greater than 60h, that is the data pointed by this r0, then carry flag will be 0. In that case, you need not update. But if the contents of the accumulator is less than 60h, then whatever is in 60h, that should be moved to accumulator, because we have already told accumulator contains the largest. Okay. So where will be the next? As we have already seen in the instruction set, for compare jump or not equal to, next will be immediately followed by the CJN instruction. Okay. So if both these contents are unequal, then a branching will be done. Now here I will check for jump on no carry. Jump on no carry to say next or n1. It means what? If the carry flag is equal to 0, you need not do anything. Okay, you need not do anything, and you have to simply go to the next data, because already accumulator contains the largest. Fine. But if carry flag is set, it means accumulator contents are smaller than 60h, then whatever is in 60h, that should be moved to accumulator. So if this condition is true, what you should do? Move a comma 60h. So what you are doing is update register accumulator with largest. Okay, and n1 will be this, and this you will repeat for until the count becomes 0. So decrement jump on non-zero, R2 comma back. So where will be the back? Back will be to the next data. This is very important. If you don't write the labels properly, it will destroy the entire logic. Okay, so I will give some gaps here for understanding the logic. Let us compile this. So let me take the same data which I had taken here for Excel. So 31289. So at 30H I have to initialize the data 3, 1, 312, 8, 9. So after the comparison, accumulator should contain the largest number. Okay, let us see the logic. Okay, only in debugging, while you do this step, okay, you will understand the logic better. So R2 contains 5. So this is because the number of comparisons are n minus 1. Initialize a pointer. Accumulator contains 3 now, that is the first data. So next location, then whatever was in that location, that is been copied to 60H. You can see it here. I will write here 60. You can see 1 has come. So you are basically comparing 3 and 1. So accumulator contains 3, 60H contains 1, because the next memory location had 1. Now when you compare, you can check the carry flag here. Carry flag is currently 0 since the contents of the destination is greater than the source. Okay, so carry flag will be still 0. Can you see this? So since accumulator contains already the largest number, so you need not update the accumulator, and it will simply skip this and go to here, and it will decrement R2, and the next memory location will be updated. So what is the next data? It is 2 now. Now what is happening? 3 and 2 are compared. Still accumulator contains the largest. That's why accumulator is not updated. So it will go again. Afterward the data is 8 now. So you can see now in 60H 8 has come. So you are comparing 3 and 8 now. 3 and 8. Definitely 8 is greater than 3. So this condition will be false. Okay. So you can see carry flag has become 1. So jump on no carry condition will be false. So it will go to the next instruction. So what should I do? I should update the accumulator with the largest. So currently accumulator is containing 3 and I will update with the largest. Now the accumulator will contain 8. Okay. So what is the count now? It is 2. One more comparison is left. So we'll compare that also. Now 8 will be compared with 9. As you can see, since 9 is greater than 8, again this will be false. It will come to this instruction, and accumulator contains the largest number, that is 9. Okay. The same program, if you want to do for the smallest, how will you do? Okay. So if it is asked for the smallest program, you have to only change one instruction. Which is that instruction? That is this. Instead of jump on no carry, you change it to jump on carry. Okay. Please execute this program. You will understand better. Thank you.